Hello, pre-calculus. This will be the fourth video for lesson 5 from section 1.4. So we've been talking about doing word problems, like working through them. Sometimes it's informally and sometimes we actually create an equation. On this next one, number 81, you'll see how both of those kind of come into play. So it says this is kind of outdated, so try not to laugh. When a popular brand of CD player is priced at $300 per unit, a store sells 15 units per week. Each time the price is reduced by $10, however, the sale increases by two sales per week. So what's the selling price that we should make this $300 unit, like we're continually decreasing it to get more units sold, if we want a weekly revenue of $7,000? So the first thing I would do is just try to figure out what this pattern is as you work your way from, hey, I'm selling it for $300 and it's 15 units per week every time. So you have $300 per unit, you sell 15 of them, and that results in $4,500. Now, what happens when I reduce it by $10? I sell 2 more. So you take 290 times 17, and that yields a revenue of more than $4,500. You get $4,930. Keep it going. Take $10 more off, you sell 2 more. So 280 times 19 should be 5,320. And really, if you wanted to, you could just keep moving all the way down here to see what, at what point would we eventually get to $7,000 in revenue. Here's the thing, though. I'm seeing a pattern. Here's my revenue, here's my price, and here's the number of units sold. So when I take price times units, I get revenue. So I can actually create an equation because there is a linear difference in the price per unit that corresponds with a different linear change in the number of units sold. So it's kind of like, if I start at 300 and subtract 10 for every, I'm just going to call it X.
All sophomores, please report to the high school gym. All sophomores to the high school gym.
Sorry for that announcement. So let's just say X is the number of iterations, like the number of times you reduce it by 10 units, okay? So this P column represents $300 that you take away $10 every time you move the price down. Here would be, it starts at 15, but I'm going to add to 2 units sold, so plus 2x, every time you move the price down. So you go from 300 minus 10x, and you multiply by 15 plus 2x, we're just trying to figure out when that will equal 7,000. So when will multiplying the price per unit times the number of units sold equal 7,000? So then it's just kind of like an algebra equation from back in the day. You multiply these two, you get 4,500 plus 600x minus 150x minus 20x squared, 20x squared. All right, and I ran out of room, but that would be set equal to 7,000. So if you're taking notes on this, put equal 7,000 on that. So then we can combine like terms. This will be 450x. I'm going to move the negative 20x squared to the front. And then 4,500 is on the left, 7,000 is on the right. If I subtract 7,000 from both sides, sorry, this is looking a little bit rugged right now. Bear with me. You get minus 2,500. All right, so you get a quadratic equation. All right, at this point, I mean, we've done this so many times, like do the quadratic formula or factor the thing. I'm going to kind of like leave that work alone and just say, you know what? No, I'm not going to leave it alone. I'll solve it with you guys. So everybody can be divided by 10 to reduce the heaviness of the numbers. In fact, I'm going to divide by negative 10 to make the x squared a positive number, and do that to the right-hand side of the equation as well. So you get 2x squared minus 45x plus 250 is equal to 0. All right, this is actually a factorable equation. What multiplies to give you 2 times 250, 500, and adds up to give you negative 45? It ends up being negative 20 times negative 25. They add up to negative 45, and they multiply to give you 2 times 250. Now here's what it looks like if you're doing guess and check. We know it's got to be 2x times x to get the 2x squared. Now we need to create these numbers by multiplying by these endpoints. So 2 times what would give you negative 20? Negative 10. What times x would give you negative 25? All right, so the guess and check factoring is a nifty shortcut. When you set those both equal to 0, you get plus 25 over 2, which is 12.5. When you set this equal to 0, you get plus 10. You get x equals 10, and x equals 12.5. All right, so now, what is the selling price to create a weekly revenue of $7,000? Well, x did not yield, x doesn't equal the selling price. The selling price is the expression for P, 300 minus 10x. So what we do is we take 300 minus 10x. This is the selling price expression. And we say, hey, plug in 10. That'll give you the selling price after 10 reductions. Reductions of price, I guess. Which gives you 300 minus 100. All right, so you can sell them for $200, and that would yield a $7,000 revenue. 12.5. Well, multiplying by 10 just moves the decimal spot. So instead of taking away just 100, I'm taking away 125. So 25 less than that would be 175. Yeah, that's interesting. You can sell them at either one of those prices to get the $7,000 revenue. Which, you know what, this actually makes a lot of sense if you understand what our function was to begin with. Our function before we divided by negative 10 was an upside down parabola. So the $7,000 revenue is going to hit that upside down parabola in 2 different spots. So we have 2 different places, yeah? And we could actually figure out what the maximum revenue would be by determining what the peak of that parabola is. But I'm not going to do that right now because it doesn't ask us to. I'm moving on to number 83. Okay, so that was good. A good degree of difficulty on that problem. So I think 83 is on the next page. Oh boy. All right, we need to turn this thing. So This is an interesting little geometric application here. So it says the dimensions, the rate at which a tablet of vitamin C, there's 2 of them here, begins to dissolve depends on its surface area of the tablet. So the first brand is 2 centimeters long, and it's in the shape of a cylinder. So think of a cylinder with open ends right there, and hemispheres coming out of the side. So think of it like, I don't know, a paper towel dispenser. It's basically a cylinder like this with hemispheres on both sides. And they say that the diameter of the hemisphere is 0.5 centimeters. Your other tablet has a height of 0.5 centimeters, and they really don't tell us anything else about it. In fact, what we're supposed to do is find the diameter of this vitamin C tablet in such a way that the surface area of this one is equal to the surface area of that one. So what we should do first is kind of just state this. At least this is what I'm comfortable with. I'm going to state it, number 83. The surface area of our first one is basically being forced to equal the surface area of the second one. So if you check out surface area formulas, the surface area of a cylinder is, so cylinder surface area is equal to 2 pi r squared. That's because there is a circle here and a circle here. So pi r squared plus pi r squared is 2 pi r squared. The curved surface area is 2 pi rh. The 2 pi r comes from the circumference of the circle. I'm not going to, look, that's the surface area for this first part, okay? Except there aren't ends here for a cylinder. So those 2 pi r squareds, they don't exist. What we actually have is one hemisphere plus an identical hemisphere creating a sphere, yeah? And if you look at any formula sheet, the sphere surface area is 4 pi r squared, okay? So this is our pill here, 4 pi r squared plus 2 pi rh. We know that the radius of this will be half the diameter. So they told us that the diameter of this pill's hemisphere is going to be, the diameter is 0.5, which means it's half of that. It's 0.25. So we have 4. We got r squared. I'm going to call it, you know what? Instead of 0.25, I work better with fractions. I'm going to call it a fourth. It's 2 pi times a fourth. And we know the height of this cylinder, well, it's the height of the cylinder is just this. Okay? You got to add a radius on the front end and a radius at the back end. So 2 radiuses, that actually is equal to this full 2 centimeter length of the entire pill. I know, this just gets trickier and trickier, right? So the radius was 0.25 or 1/4. So double 0.25 is going to just be, a half. So your height is going to be 2 minus a half, which gives you 1.5. All right, so h is 1.5. I like to go with fractions, though, so that's the same as 3/2. All right, here's the left-hand side of our equation. 1/16 times 4 and 6 over 8, so it's 3/4. So it's 1/4 pi plus 3/4 pi. 4/4 pi. It's pi. All right. The surface area of the left one is 1 pi. Now, what's the surface area of the other one? We can just straight up go with the formula that I originally had for the cylinder. So the original formula for the cylinder was there are two circles at the top and bottom of that cylinder. And so it's 2 pi r squared. By the way, this r is special. It's not the same as the r here. It's a completely different pill. So I'm going to put r2 there just so we're not trying to plug in 1/4. We know the height's a half, so we can plug that in right there. So you got 2 pi r2 squared plus 2 pi r times a half, which is 2 pi r squared plus pi r2. Move all this down. At this point, I'm just going to go back to regular r for the radius. All right, at this point, everybody's got a pi. And since it's just a constant, I'm going to divide both sides by that pi. Which creates a quadratic equation. 2r squared plus r minus 1 is going to give us some kind of value that will be helpful for this radius. Or we'll find what the radius is with this equation. So quick guess and check says it's going to be 2r times r. And we need a positive in the middle, so that's how this is going to go. Yeah. Well, this one equals, r equals a half for 2r minus 1. This one, r equals -1. It's kind of absurd to have a negative value for a radius. So, the radius is a half. Find the diameter of the second tablet. We know the radius. Now we just double it. So 2r is the diameter, so it's 1 centimeter. Wow. Okay. Part A, done. The second part is just finding the volume of each tablet. So all they're asking you guys to do is say, can you come up with a volume formula for the cylinder with basically a full sphere attached to it? So we'll say the volume for the first one is going to be cylinder is pi r squared h. And since we're just talking about the space inside, it doesn't matter that the spheres are kind of globbed on the outside. It doesn't matter that the pi r squareds here and here are covered up. It doesn't actually like fill in or take away area. Not area, volume. And then you add that to the volume of a full sphere, which is 4/3 pi r cubed. Which we know that 1/4 was the radius, and the height was 1.5. So you can do that algebra any way you figure out how to. This is going to be 1/16 times 3/2, so it's going to be 3/32 pi here. And then over here it's going to be, well, 4/3 times pi times 1/4 times 1/4 times 1/4. You can cross cancel one of the 4's and get 16 times 3 on the bottom, 48. Using our handy dandy calculator, just to make quick work of this. We get 11 pi over 96. Centimeters cubed. So cubic centimeters makes the most sense here because it's volume. All right, and then the second one, you're just doing pi r squared because it's a straight up cylinder. We figured out the radius was a half. The height was a half. So, mercifully, it's a much less rigorous calculation. It's 1/2 times 1/2 times 1/2. All right. Now, just one point to make on this. It seems to me like the lower volume would be the one you would want to manufacture more of because it would actually reduce the cost of creating it. Because it takes less material to make a pill that has less volume than something else. So I guess if you're manufacturing pills like this, you would do this math and figure out that if the surface area is what causes the dissolution, the dissolving of it, 1 divided by 8 is 0.125. 11 divided by 96 is 0.1148. This pill right here, after you manufacture 20 billion of them, that 0.101 cubic centimeter that you save every single time probably adds up to quite a bit of cost. You reduce cost that way. So, long video. We only got through 2 examples, but I think it was rich enough to, it was worth our time. All right, see ya.